Alright, so we're back with round 2 of our notes, and this is actually going to be the last set of notes we take for the rest of the 9 weeks. This is going to wrap up our set of notes that we started taking on the last classification of matter involving acids, bases, and salts. So we learned the other day that acids and bases are kind of on two separate ends of a spectrum in terms of how different solutions react with water and the different characteristics that they have. And so because they have two opposite ends of the spectrum, we need to talk about what's in the middle, and that's called a salt. So salt is defined as any ionic compound that can be made from the neutralization of an acid and a base. So basically, if I put acid and bases together, they neutralize, and we end up with ionic compounds because electrons are transferred from one element to another. So it's made from the positive ion of a base and the negative ion of an acid, and these are the things that break off when we have them come together in their chemical reaction. So when I look at a salt, if I were to be able to look at it like through a magnifying glass or even through a really powerful microscope, the way that the molecules arrange themselves are like a crystal. So just think of like the grains of table salt look like tiny little crystals. If we were to dip litmus paper into a solution that has salt in it, the litmus paper is not going to turn any color. So if I put blue litmus paper in, it'll stay blue. If I put red litmus paper in, it's going to stay red. So we've got some formulas here to learn for salts as well, and their uses are already written down for you, which is really nice. So we have sodium chloride, and that's the one that we use most often. Potassium iodide is sometimes added to food later on in life. If people have an iodine deficiency in their diet, that would kind of help take care of bringing in more iodine into their food. Calcium chloride is what's used outside for like rock salt, for de-icers. Potassium chloride is used as a salt substitute. Sometimes people end up having too much sodium in their diet, and so they can switch out that type of salt and still be able to flavor their food. Calcium carbonate is used in limestone, and ammonium nitrate is what's most often found in fertilizer. And this is because of the ammonium and the base ammonia, and then nitric acid, when it comes together, it creates this fertilizer. So a neutralization reaction is what we just talked about, and that's how salts are formed. And again, this is when acids and bases react to form salt and then water. So our example here, we have nitric acid, which is this, and potassium hydroxide react, and what we get is water and potassium nitrate. The way we get water is because I have the OH break off of the base, and then the H breaks off of the acid. And so these two guys come together and create water, and then what's left over is the NO3 and then the K, and that all comes together to make your salt. So in terms of strength, it tells us how well acids or bases produce ions in water. That basically means when I pour them into water, how easily do they break apart. So the strength of an acid or base determines how safe it would be for us to use, especially if we were to have it in class, and if someone were to spill some on their skin, how quickly would we need to get them cleaned up before they start to get some kind of injury. So pH is it actually is an abbreviation for percent hydrogen. It expresses the concentration of hydrogen ions in a solution. So I've had students ask me in the past, why is the H capitalized? So remember, hydrogen's symbol is H, and we always have a capital letter to represent that. So now you have that explanation. So there's a range of values for pH that goes from 0 to 14, because we've said that acids and bases are two ends of a spectrum. So kind of like a rainbow is the color spectrum, where colors kind of gradually change from one to another. Acids and bases are kind of the same. So there are different levels of being an acid or a base. And if we measure the pH of a solution and it ends up being between 0 and 6, we can determine that it is an acid. If it is from 8 to 14, it would be a base, and the number right in the middle is 7, and that would be considered neutral because it doesn't really lean to one side or another. So the farther away a number is from 7, so the further to the outside of the spectrum it is, the stronger the acid or base would be. So an example, if I dipped my pH paper in a solution and it matched the color for 1, it would be a strong acid. pH with 6 is a weak acid. A pH of 14 is a strong base, while a pH of 8 is a weak base. So the closer it is to 7, the weaker it would be. So this picture illustrates where a lot of like common household items would fall on this scale, from acid, which would be like the strongest at hydrochloric acid, to the strongest base, which is at the bottom in the blue. So just take a look for a second and find some things that you're familiar with and find where they would fall on this scale. So when we do this lab, to find out if we have an acid or a base, a litmus indicator test is used. And this is when you have blue and red paper. The blue paper turns red if it's an acid. Red paper will turn blue if it's a base. So remember those 2 clues when we're doing this lab. And finally, to learn the strength of acids and bases, you can use a pH indicator test. And this is a golden color that will turn a specific shade, and you can match that color up to a chart which has a pH number assigned to each color. So we'll get practice with that in class. So this is it for our notes. Be sure that if you have any questions that you jot them down and then come into class ready to ask them. Otherwise, be sure that you read over your lab before we come into class. That way you'll know what to do, and we'll just kind of quickly go over it before we get started. Hope you'll have a good one.